Hello there, welcome back to my channel. In today's tutorial, I hope to demonstrate the use of one of the functions that I've just finished writing. And again, this is part of an ongoing effort that I'm doing. I'm putting together a library that it's more of like a computer vision application. So it has like several tools that are like based on computer vision or image processing. We think of them that way. And these two kind of like help researchers to be more efficient. And so for today's demo, I am working on extracting colors from imagery or from figures. So you have a figure from a paper that you love, the colors they use for that particular figure, and you want to use those colors. Sometimes it's hard if it's not like the primary or the popular colors, then it's very hard to like track down those colors to so you could reuse them on your figures, maybe to make different plots. In this particular program, I have written this code that all you need is to just make a screenshot of that particular figure, and you provide it the path to where that screenshot lives, and you run this code, and it will give you the name of the colors they use. It will plot back that figure, and also let me just show you what we are expecting at the end of the day. So for example, I have this as an example input, so it doesn't have to be a figure only, it could be any image. And let me just demonstrate an output. So I'm going to open where I save those stuffs which are here. I need to close that. This palette color is the final result. So if I just preview this is how the final result looks like. So that image I showed you earlier is this image, which is the input image, and I assumed that I needed to make 18 lines for my plot, so I'm able to extract 18 colors from here. I'm going to show you how to do that, but it could also use as little as 2 colors, so you could just extract 2 colors, and again it's based on it extract them based on the percentage composition. So if it's green that is dominant, green will be sure part of those few lines that will be extracted. Well, I'm already taking too much time to explain. Let's get into the code, and I will run this and explain this further. And so the idea for this particular project is that you have a figure, or you have a scene, you have a picture, or that you have some colors that you like to use in your own plot, or you just want to know which colors those people use. You just have to run this function and provide a screenshot of that figure to read, and it's able to tell you which colors those people use. And this is particularly handy when you're like trying to make your publication figures and you are taking into consideration color blindness and stuff. And this particular one also kind of like classifies those colors and tell you which one is colorblind friendly and which one is not. So it doesn't just extract, unlike, I mean, there are some already code out there that could do the extraction, but to the best of my knowledge, there is no code that will tell you from those extraction which one is colorblind friendly and which one is not. So I'm hoping to fill up that gap with this particular project. I'll be explaining more as a code, but I think my time is running really fast, so I will try to go a little faster. So to start up, as usual, we'll define our function, and for this particular function I'm calling it extract color blind safe palette. So this is my mission. It's not just to extract colors from those images, but it needs to be, we're focusing on those color blind on colors from those images. So it could be figures, doesn't, when I say images, it could be figures, it could be anything, it could be a picture of a car, it could be a picture of anything at all that has color. So you just need the color image and you're good to go. And so for this function, we'll be taking in the input to the path of that picture you took. It could be a figure, a screenshot of a figure or whatever, and then the number of colors that you want to extract from that image. This is usually tied to the number of lines you are planning to plot. So suppose you're making a figure that needs 8 lines or 12 lines, then you set this number to that. So it will basically extract 12 colors from that, and it's based on the dominant colors in that image. And then there is some other default parameter variable set here. You don't have to worry about this, or you want to change is just this one and this one to provide that one. Next, so we have successfully defined our function. And this is just a little doc string, again, just summarizing what I've just explained here. And then we'll get our import. These are the main libraries that we'll be using for this particular project. And we'll do some housekeeping. We'll just prepare some paths to where we save this output. So our output are the figure, so we're plotting that figure that you provide back to you, just so you are sure that you're operating on the right image. And by the side of that figure, we're also plotting those color palette alongside, and those number of the palette or number of colors provided back to you should match this input that you provided, that I was just talking about not too long ago. And so this is just setting those. Again, this is just pointing back to where you provided your image, so it will be saved into the same path. Again, you could adjust this output directory to be wherever you want, but for now I'm just leaving it that way, just for the testing. And then next, before we go into this coding the extraction of these colors to be able to classify, to tell us which one is colorblind friendly and which one is not, we need to first understand what this color blindness. So color blindness is just essentially, think of this as like it's an illness. You could think of it that way, or think of it as some effects on the eye, some defects on the eye that would not allow some people to correctly see some colors. So some people could be blind towards red, so they will see an image that that have like the normal, your cones in the eyes are working properly, we're able to see red and know that, oh, this car is red. They will not be able to differentiate the red from other colors, so they may not necessarily see the red as the red. So sometimes when we make figures for publication and then you're using red lines, and and you use green lines, some people struggle differentiating between the red and the green that you are kind of like referencing in your text. So it's always good to like select colors that are colorblind friendly, and that is my mission here, is to be able to ease the extraction of these colors. So one of those is this one called the protanopia red, which is a form of like a red blind. So basically the red perception of color is weak for this kind of like defects on the eyes. And basically the effect is that the red and the green becomes harder to distinguish. So that's like the consequence of having this sort of like color blindness. You don't necessarily have the ability to differentiate between red and green. So if you're making a figure that has a jet which runs from green, which has some green and also red in it, then it's hard to like distinguish those two. There are also other two, which are the green blindness by this name. And again, just read through this text. I want to go a little bit faster. And the other one, which is a bit rare, is this one, which is the blue blinder. So these are the kind of, I think of that as the primary colors, the red, green, blue, which the primary these are the channel that you load your color image. The colors are distributed across, and like for someone struggling to identify any of this one could be classified as or be considered to have some color blindness. So that's about, you could read more about color blindness, but again, here I'm just like introducing this because we'll be doing some calculation to that will involve some metrics that have already been like totally researched. So there are some metrics out there that would be able to like describe how people that have this sort of defects would see color. So we're able to modify our input image to match how they would see those color, or how to see those image. And we also modified our input image to how these people will see the colors, and also how these people with this effect will see the colors. And so that's the idea. And if we have those metrics and we evaluate it on our image, then we'll be able to see our image the way they will see those images basically. Again, I'll be doing future videos to explain this more in detail, but I think this is not the main point of this particular tutorial, so that's why I'm going a little bit fast. But here is the metrics. So again, I got this from online. You could just look into the metrics for color blindness for these different types. So for different types, having this one as a red weakness, so they can't really differentiate the red. and then having the green, and then having the blue weakness in vision. So this is the metric. This is all we need for now. And once we have this information, we can evaluate this on the image we loaded, and from there we could be able to like see this image the same way they see, so we could be able to know which colors we should drop off or something. And so the next step is to load these images, which is just what we're doing there, and then we'll calculate the k-means. This is just a way of like classifying those colors that we'll read from this image. So we have some intensity values here. We also have the intensity corresponding for different color channels. We could use k-means to like classify them in red, green, blue sort of stuff, and know the frequency, the amount, or the intensity, that basically amount, the count of how much each of those channels is present in that image. And so that's also what we're doing there. And once we have that, then we'll now apply what I explained earlier. So basically we're simulating the color blind here in this function. So just picking our image, which is a red, green, blue, and then the metrics which are provided for the different people that have different blindness, color blindness, and then we evaluate those by multiplying them and then clip them so everything can normalize stuff. And then once you have this function, you just run it on our input image, which is just basically what's provided here. And if you do that, then we're able to have images that look like the way people that have those colors will perceive those image. And once we have those, then we are actually ready to like format the result, classify them, and then print out the summary. So basically here is just printing out the summary of what we saw in those images, and we're also plotting our raw image and also the palette that we found. And this again will be based on the number of colors that you requested for, and then we could return our results. And the next step would be to just call this function, provide the path. Again, these are the two inputs here. I'm requesting for about 8 colors and telling it where it should say where my input image is. And again, my output will be saved in the same folder, but this name will be grabbed, and then we'll add the palette here alongside the summary, which will have like the code, or basically think of it as a name for the colors in the images, will be shown. And also we'll be having a tick by alongside on the images to tell us which one is color blind friendly and which one is not. So with that very much long talk, let's run this code. Let's run the code, and it should make a figure. So this is the figure that it made. This is the input image I provided, and these are 8. So this 1, 2, 3, 4, 5, 6, 7, 8 colors because we requested for 8. And the ones with an X here is telling us that this people with color blindness will have issue identifying these colors. So these are the better ones to use. So if I'm making a plot, then I will consider using colors, this sort of colors, rather than this colors kind of deal. Great, so that's that. This has also been saved. Again, in your terminal, you also be getting a table that looks like this. It also just gives information on how many colors have been extracted. It gives you the hex code, which you could use this code to just copy it and paste on your plotting wherever interface. It could be Python, Matplotlib. Just provide color is equal to this, and then to be able to extract that color. And again, on this side, we'll get the message of the color blindness safety, whether it's yes. If it's a yes, then you could use, so this the yes that we saw there. So I will just basically copy this patch and paste it to my code, and voila, I'll get that that color that I've been looking for. Yeah, so that's that. I'll end it here, but if you have any question, please drop it in the comment section, and I'll be happy to come back to answer. Please, if you have not subscribed, please consider subscribing for more content. Thank you again, and bye bye. See you in my next video.